Let's continue on here with B. And remember, these are ones where there is no longer does every term have a logarithm. So if you look at the previous ones, something like this, there's a log in that term, there's a log in that term, there's a log in that term, there's a log in that term. Every term had a log, but then what we just did, log on that term, no logarithms. So that's how this is different. Log there, great. Log there, great. None. So when these happen, you want to get the logs alone on one side. So that's what's happened here. They're not alone. They are alone, but they're not together. It's not only you haven't combined them yet. So we can combine them. Now because they're adding, we can use the log law that says we can multiply. And it's a log base 6. So therefore I can go 6 to the power of and 6. So these can just cancel out. That's gone. And then I've got a 6 squared here. That's a 36. Now for here, I can go x times x squared plus 4x minus 1x, and then a minus 4. That's very poorly written. But anyways, I can minus this 36 over because I see that it's a trinomial here. I mean, I got an x squared and an x. So I've got an x squared. Those can become a positive 3x, and then this becomes a minus 40. So hopefully this is factorable. X and x, 8 and 5, and that has to be negative. So then I get a negative 5 and a positive 8, which is positive 3. Okay, yeah, that works. So I have an x plus 8 and an x minus 5 is equal to 0. I'm going to write this up here. So I have an x plus 8 equals 0, or an x minus 5 equals 0. I can bring over the 8 by subtracting, which I'm not going to do. I'm just going to write minus 8. And I'm going to bring over the 5 by adding, which I'm not going to do. I'm just going to write 5. So do any of these work? We have to take these in here. Take the 5, put the 5 into here, you get 9. That's fine, that's a positive number. Take a 5, put it into here, you get 4. That's fine, positive number. Take the negative 8, put it into here, you're going to get negative 4. That's not allowed. Put it into here, you're going to get negative 9. But it rejects twice. It only needs to reject once. So that is rejected, meaning x equals 5 is your only answer. Now I didn't realize I had so much space here, so I actually will move this for you to copy down. You can, but the notes are probably a little bit neater. Okay, so the next one. We want to combine these together to get the logs together. So we've got log base 6, and we've got a 2x plus 1, and because they're subtracting, we can divide. X minus 2 is equal to 1. Now there is a 6 here. We just did that again, so 6 to the power of and 6 to the power of. Maybe I'm not being very creative here, having all these 6's as my bases, but whatever. 6 to the 1 is 6. Now I'm going to put an x minus 2 on the numerator so we can cancel with the denominator. And I have to do that to the right side. So I have a 2x plus 1 equals a 6x minus 12. Okay, so let's bring the 2x, we'll subtract that over to here to get, I guess that's 6 minus 2 is 4. And then I'll add the 12 to the other side. And I'll get 13. Now if I divide that by 4, oh great, what on earth is that? And I know 12 over 4 is, so like I know 12 over 4, that's 3. This is just bigger than 3. So it's 1/4. So I got 12 over 4, and then I have another 1 over 4. That is 13 over 4. 1 over 4 is 0.25. 12 over 4 is 3. So this is 3.25. I'm sure you could do it some sort of long division way, but 4s aren't too bad. So I need to take 3.25 and see if that fails anywhere. Put a 3.25 into here. That gives you a positive number. And put 3.25 into here. That'll still give you a positive number. So it'll work. 3.25 minus 2, what is that, 1.25? And then the other one is clearly positive. So that works. So I'll zoom out for you to take a look. and then we can go right on to example 2. This looks maybe a little more difficult, but it's not too bad because you just have to do one step where you're going to bring this log base 8, because remember how I said you wanted to get them together on one side, so we want to bring it over here. So now it's over there. But then this 5 is in the way, so I'm going to move the 5 over to there. So on the left, I've got a log base 8 of x minus 2. Oh, this is a 4. I don't know why I wrote 2. This is an x minus 4. Plus a log base 8 of that x minus 4. So I've got the x minus 2 and the x minus 4. And on the other side, I have 6 minus 5, which is 1. So I can combine these together now, because the whole idea is get them alone on one side and then combine them. So I have an x minus 2 times an x minus 4. So I'll have to expand that or FOIL it or whatever word you use. So 8 to the power of and 8 to the power of. I am left with an x squared minus 4x minus 2x plus 8. X squared minus 4x minus 2x plus 8 is equal to 8 to the 1 is equal to 8. So I can subtract this over. This looks like a trinomial, so I'll subtract that over. And what do I have? I've got an x squared minus 4 and 2 is minus 6. 8 minus 8 is 0. Okay, so I don't write it, and this must be a 0 too. And these ones I really like because they seem like, oh, how can I possibly factor that? I'd need 3 things here. And it's actually a lot easier than that because they both have an x in it. So you can take an x out and you're left with just an x minus 6. So I've got 2 answers. I've got an x equals 0 and an x minus 6 equals 0. So I've factored it really easily by taking out just an x. This one is done, and this one you have to add the 6 over to the other side. So now I can check to see if these fail anywhere. So if I put 0 into here, 0 minus 2 is negative 2. Failed. I can't have a negative number. So that one's rejected. How about 6? 6 minus 2 is 4. 4 is okay, it's positive. 6 minus 4 is 2. 2 is okay, it's positive. So I only have to reject this one. And yeah, just 6. So I'll zoom out here. We've got one more question to do. What was more difficult about that? I don't really know. We just shifted this log 8 to the other side and moved this 5 over, and then it looked identical to every question that we had previously done, the other 3 or 4 or whatever. This one, we don't even need to move anything, which is kind of nice. So this is in no way different. I should have put this one on this side. And may just subtract it, but for whatever reason I did not do that. So I will, in fact, let's do that right now. I will change this. So yours will say a minus log 3 x minus 3. So that's what yours will say. So step number 1 would be to add the log 3 x minus 3 to both sides. Log 3 to x minus 3. So those are gone. So I have log base 3 of 2x plus 1 plus log base 3 of x minus 3 is equal to 2. And now I can combine these. 2x plus 1 times x minus 3. So 3 to the power of and 3 to the power of. So what do I have here? I got a 2x squared minus 6 plus 1. 2x squared minus 6x plus 1x minus 3 is equal to 9. Let's bring that 9 over. So I've got a 2x squared minus a 5x. Negative 6 plus 1 is a negative 5. And then this is a minus 12. Now, is this factorable? 2x and an x. 4 and 3 make that negative to the negative 12, and my diagonals are negative 8 and positive 3, which get me the negative 5. So yes, I've got a 2x plus 3 and an x minus 4 is equal to 0. So I have a 2x plus 3 equals 0, or I have an x minus 4 equals 0. So subtract the 3 over, which gets you a negative 3, and divide by 2, both sides, gets you a negative 3 over 2, which is a negative 1.5. So we'll need to check that. That is a negative number, but it might be okay still. And then add the 4 over there. Okay, so 4 and negative 1.5. Let's take a look. Okay, put a 4 into here. That's okay. That's fine. That gets you a 1. Put a 4 into here, you get a 9. That's fine. Negative 1.5. Put negative 1.5 in here, you get a negative 4.5. Immediately rejected. I don't even need to check anything else. There's a rejection there. So I'll reject that one, meaning our answer is just x equals 4. So that should be it. Yeah, because after that is just the worksheets. We've done a lot of questions. These are all relatively straightforward. And you never had to use a logarithm. You had to just have logarithms. They were in the question, and you had to make them exponents in order to solve. So the next section, I'll give you exponents, and you will now have to use logarithms to solve. So here we had logs, and we use exponents. There we'll have exponents, and we'll use logs. So that is the plan.